Hello everyone, welcome back to my YouTube channel. My name is Sagar.Utekar and today is day one of our free CKA series. We are going to discuss the container fundamentals. Even though Kubernetes has removed the default runtime Docker in Kubernetes release 1.24, I feel we need to understand the container fundamentals before jumping into the uh, complex Kubernetes topics. Okay, so three main fundamentals we need to understand. What is a Docker file? What is images? And what are the containers? That should be enough for your CK exam and for your CKD exam as well. Okay, I'm going to keep this video very short. We are going to only cover the topics and the fundamentals required for a CK and CKD exam. I have another video which will help you to understand the container fundamentals in depth, which you can find on the free CKD series playlist. And the video link is here in my GitHub. Okay, so let's start with the container fundamentals discussion. We will understand the traditional deployment model, virtualization deployment model, and the container deployment model. So in traditional deployment model, um, developers used to buy the physical servers, the costly physical servers, which used to take a lot of time to set up the environment. And on the same physical servers, they used to run the different application on the same physical server. So the problem with that approach is that um, some of the application used to take higher consuming the more resources, which was causing the issue for other resources, and they were not getting the enough resources. Okay, that's a problem. So if application is not getting enough resources, they will not run as per our expectations. So some of the applications were getting crashed. So that problem we need to solve with the virtualization and the containerization technology. That is the first problem. The second problem, as we discussed, the setup time, and the third problem is the cost for buying the physical servers. Okay. One more problem I see here with this traditional deployment model was security. If one of your application has this security vulnerability, some security concerns, then that is going to impact for other running applications, as well as the host operating system or of the physical server. These are the main concerns of the traditional deployment model. Even if we have documented all the steps required for running our application and provide it to the developer, what are the chances they will follow the exact steps and they will create the environment? So let's say today I bought one physical server. I ran my application. Okay, and after some time, there is a huge traffic increase for my application. I want uh, different physical servers to run the same application. I'll buy that physical server. I'll set up the same infrastructure, but there is a possibility that I may miss something while setting up that infrastructure, right? So that is one problem with the traditional deployment model. Let's come back to the virtualization deployment model, what we were doing. So in virtualization deployment model with a hypervisor, with the help of hypervisor, what we do is that we create a different virtual machines which will run on the same physical servers. And each virtual machine can have the different operating system. Let's say one of my application requires the Ubuntu version, one of my application requires Red Hat version, and maybe Windows version. So I can create a multiple virtual machines which can run on the same operating system. Okay. Yeah. So that is the advantage of virtualization. We can run multiple different operating system inside the virtual machine. Now, since we have reduced the cost of buying the physical service up to some level, now and also the management of the resource utilization up to some level. Okay, we can start running our different applications on the different virtual machines. But the problem with the virtualization deployment model is the setting up the operating system virtual machine as well as the booting time of virtual machine, because Again, even if we are running multiple operating systems which are sharing the base hardwares, um, it is consuming the resources as well as it is using the full-blown operating system, which may have the unnecessary packages and the softwares which are not required to run our application. Okay, so that is one of the problem with the virtualization deployment model. The next and the best option for us is the container deployment model. What we are doing with the container deployment model is that using a container runtime, we can run multiple containers, like hundred or thousands containers on a single physical server. Okay. And each container will have the smaller version of the operating system, the packages, binaries, dependencies, and the everything which is required to run our application. If we consider the operating system size of the virtual machine, which might be in GBs, here in the containers, we will have very smaller operating system, maybe in MBs. Now you can see the difference, GB and the MB, right? So in a container, we will only put the things which are required to run our application. And this is how the container deployment is very faster as compared to the traditional and the virtualization deployment model. Now we have solved major problems like a cost. We have reduced. We don't need to buy multiple physical servers. We and the boot up time is very faster because the container footprint is very small. The security concern, because containers are lightweight and very smaller in size, the security footprint is also very small. So even something goes wrong in a container, it will only affect to the container where the um, issue is. Okay. The yeah, so that is the basic of containers. And then what is a Docker then? Why we are learning Docker when Kubernetes has already removed the support for Docker container runtime? I'm going to answer that question slowly in one more video, but let's understand the Docker. What is a Docker? So Docker is a platform. It has everything required to manage your containers and your images as well. Okay. So as we discussed, the Docker is a platform that enables you to package and run your applications into isolated environments called as containers. So that is the basic definition of the containers. Containers is an isolated environment which will have everything to run your application in isolated format. Okay, this is basic Docker architecture, and it has everything you need to know. What there are four main components: the Docker client, Docker daemon, Docker host, and Docker registry. Docker client is what we will install the Docker CLI as a Docker client, which can help us to interact with the Docker daemon, which actually takes care of managing your images and the containers. Okay. And the last part is the Docker registry. So Docker registry is somewhere you can consider as your pocket where you store your Docker images. Now, the main, as we discussed, three main fundamentals we need to understand from this video: Docker images, Docker containers, and the Dockerfile. So consider these as a flow. So we write a Docker file which has the all instructions to run our application. It is just a file with the instructions. Using that file, we create a Docker image. Docker image is a read-only template which contains the instructions for creating your Docker container. If you want to share our application with some other developers and they want to run on their machine or somewhere, anywhere in the world, on cloud virtualization, virtual machines or the physical machines, anywhere, we can share the our application in the form of images. Okay, and the containers using Docker images, they can create the containers in their environment. So that is those are the three main fundamentals we need to understand. Okay. So for practical, I have taken the getting started app from the Docker official documentation. We will install the Docker desktop first. Let me check if we have a Docker desktop. Otherwise, we'll install the Docker desktop. Okay, so let me check. I don't see Docker desktop. I wanted to explain everything on the clean slate. So that's why, yeah, desktop is a all-in-one package to build images, run containers, and so much more. So it will have your Docker client, daemon, and everything inside one package. So let's download the Docker desktop package. If you're using Docker Windows, then you can click on this link, install instructions, and follow those instructions to install Docker on your Windows machine. If you are using Linux, then you can follow these instructions. Okay. So let me start installation of the Docker. I'll put this into application folder. It is copying my Docker application into the Mac applications. Okay. I think my Docker is installed. You can see here. Let me start my Docker desktop. It's taking some time. Okay. Yeah. The Docker engine has started, and you can see this is a Docker desktop UI. It will show you the running containers, running images, volumes, builds, and extensions and everything. So for these CKA series, we only need to understand the containers and the images for now. What I'll do, um, let's go back to, okay, let me start the terminal from the Docker desktop. This is my terminal, and you'll see Docker CLI is already installed here. So I'll just run the Docker command and it will show me all available commands for my Docker. Let me clear this. We'll try to start our own container using the sample application here. So let's clone this GitHub repository first and go to our Docker desktop. Okay, let me move to okay, let me remove this first and let's clone the repository here. This is a sample application. Let's see what is there. So I'll just run the ls command to check what is inside this. Let's move inside this folder, getting started. And let's check what are the files here. So there's a docker ignore file .git, readme, package.json, spec, src, and yarn.log. We'll, as we discussed, so we need to write a Docker file to create a Docker image, and from a Docker image, we can start the Docker container. So to write a Docker file, we need to create one file called as Dockerfile, and we need to put some of the instructions to create a Docker image. So this application is based on the Node.js. So I'll just copy all the instructions here into the Docker file, and then I'll explain what are those instructions. Okay. Okay. So let's talk about what are the instructions we have here. So as we discussed, so we need a Node.js environment to run our Node.js application. This is Node.js application. So from these instructions you need to use into your Docker file, which will provide you the Node.js environment. You don't need to install Node.js on your local machine. If you put these instructions from node colon 18 alpine, 18 alpine is a version of the Node.js and the smaller version of Node 18. So it will provide you the Node.js environment to run your application inside the container. The second instruction is the working directory /app. So inside the container, we are going to initialize /app. App is as a working directory. And then the next command is a copy. So what we are doing, we need to copy the files from our local machine inside a Docker container so that application inside our Docker container can have all those files. So we are copying all the files with the copy dot dot, which means copy files from my local machine inside the Docker container. The next command is a run. So we are going to use a yarn install hyphen hyphen production command to install all the packages required for our Node.js application. The next command is a CMD, and in array, we are running a node src index.js file. So this is the actual command which is going to start our application container. And expose 3000 is the last command we have put into Dockerfile. It is for the documentation purpose only. So this specifies that our application inside the container is going to run on the 3000 port. So consider these as like, okay, so let me explain this. This is very much important. Okay. So yeah, so this is my machine, and somewhere here I'm running my application inside the form container. So what we are doing is our application is going to run inside this container on the port 3000, and to access that container on my local machine on some port, I need to expose that to some port. So this 3000 port is the container port, and then while starting a container, you need to specify the port where we can access our this containerized application. So this is for now, I think it should be enough. Okay, let me go back. I'll just save this Docker file, and using the Docker file, the next thing is can I clear this screen? Clear on this. Okay, perfect. Yeah. So to build your image using a Docker file, we need to run one more command called Docker build. Okay, let's start. Let's run that command. So the command is docker build hyphen t getting started dot, which means we want to build a Docker image from a current directory dot, and the tag should be the getting started for this Docker image. So let's build this. If you notice all the instructions running here, so it is actually executing what we have defined in our Dockerfile. So this is from instructions and then working directory, copy yarn command. So it is fetching the packages and installing all the packages and everything. The actual CMD command is going to run when we start the container. So yeah, our image should be ready. To verify our image, we can run the Docker images command, and you will see here the Docker image is present with the name getting started. The tag is latest because we did not provide any tag for our Docker image. It got created 16 seconds ago. And the size of this Docker image is 347 MB. Okay. If you actually compare this with the virtualization or the traditional deployment model, it would have taken the physical servers and the setting up the Node.js environment. That is going to be a different time. In addition, as well as the size of the applications, if you consider the everything, then it would be very larger. Okay, so now we have our image ready. We can start our container using a Docker run command. Let me use these. Yeah. So what we are doing here, as we discussed earlier, we need to use the image to start our container. So Docker run hyphen dp and some port colon some port and the container image. So kind of image, we want to use the getting started image. This is a port of our container application, and this is a port where we want to listen that container application on our host machine. Okay. So you can use the Docker ps command to check all running containers, and you will see our container is running on the port 3001. You can also check the running containers and the images from your Docker desktop as well. So here you can see the ports, the container name, and the image used. You can also check the images present here. Okay, so let's try to access this application. So if you click on this, it will take you to the browser, and this is our application running on the 3001 port. Okay, so this was very quick. Right? If I want to share this application to one of my developer or someone else, I can directly share the Docker image with them. But how I can share my Docker image, which is present on my local machine, to the developer, which is sitting somewhere in the world. So to share your Docker image, you need to push your Docker images to either public registry or the private registry. So for now, we will push our Docker image to the Docker hub. What we'll do, we will tag our Docker image um, using Docker tag command. So Docker tag the current image and push it to the my Docker hub account, learn with Sagar / getting started. Okay. So this is a new tab. If you check the Docker images now, you will see one more image is created with the name learn with Sagar / getting started. And now if I want to push this image, I can do the Docker push and the actual new tab. Fail to authorize, fail to fetch anonymous token. Okay, I think I need to log into my Docker hub account. Let me log into my Docker. You can also sign in from here as well. So learn with Sagar is my Docker Hub username. Let's try to, now we are authorized to push our Docker images to Docker Hub. Let's try to run the same command again. Yeah, it is pushing all the layers of the Docker image. And if you go to my account, learn with Sagar, we should be able to see the getting started image is there. And my Docker Hub. Um, Okay, this is the newly built image we are pushed. Now, if one of my friend wants to run the similar application, they don't need to set up Node.js. They don't need to set up the base machine or anything. They just need to um, use the Docker pull command, same command Docker run, and then they can start the containers similarly. So they can use my image which is publicly available on the Docker. Okay. So I think this should be enough for us, CKA. If you want to learn more about the container fundamentals, you can go to this video and check out all other options available in the Docker file as well as the different Docker commands. Next, we are going to discuss about the Kubernetes architecture and why container Kubernetes removed the support for Docker container runtime, what is the replacement for that, and many more interesting facts. So I'm looking forward to see you all of you again in the next video. Thank you very much for watching it to the end.